So I'm Philip. I work for Elastic. I've been doing that for 8 years, and I want to show you a bit more on the RAG side around vector search, what you can actually do today. So one thing that I have tried to show you before is like this square of like how much memory you need to do. Is like we reduce the dimensionality in terms of like how we represent one vector dimension. And one interesting trick that we play is this is the space where your numbers for kind of like the 4-byte representation can be. Most of the time, you have this normal distribution that you have like a peak in the middle and then you have not much on the outside. And the trick to optimize this is you don't just reduce the dimensionality, but you basically reduce this space. So you basically cut off here at this red line, and then that's what this little peak here is on each side. And then you kind of like spread out that space a bit further, that with that 1 byte, you have a bit more precision for where it actually matters. So you squeeze out more precision by cutting off the space and then expanding that into just a single byte rather than float. And that's why this reduction from 4 bytes to 1 byte gives you almost the same quality in results. And by default nowadays, since the last 2 minor versions, we do that automatically for you. So if you give us a model with 4 bytes, we will automatically quantize that down to 1 byte to save you 3/4 of memory and make that cheaper for you. And we keep evolving that. We also support half byte. We have done various benchmarks of like how we can improve the recall. Something you might do is that you have a multi-stage approach, that you have like a coarser search algorithm first. You overfetch, like let's say you get 500 documents rather than the 10 you want, and then you re-rank just those 500. And you use a more expensive method on the re-ranking phase, but that's kind of like your coarse filter to get to the approximate area where you want to go, and then you get the fine-grained extraction at the end. We have also done various improvements in the implementation of like concurrency and using different instruction sets. So things keep, with every minor version, we keep some improvements in terms of performance. To get data in, and I don't want to spend too much time on the ingestion because I always feel that's like the boring boilerplate code, but we have connectors to pull in from various data sources. So if you have PDFs on Amazon S3 lying around, we can just pull those in and then make those searchable. Or various other sources from where you can pull in data to make that easier. Also, we have full ecosystem, for example, with all the major cloud providers. We tie into like their infrastructure to pull data into Elasticsearch and make it searchable. And for developers, we also have various language clients. So that is how most of you will interact with that you have Python or JavaScript or whatever other language you have to pull data. Llama Index and LangChain are the 2 frameworks that are very popular in the Gen AI space to tie all of this together. We are also highly rated on those and well integrated. We just had a very big meetup on Monday with LangChain and AWS here in San Francisco. So those ecosystems are very tight and give you the results or allow you to build what you need to build. And then we come to RAG, retrieval-augmented generation, which is kind of like all the rage now. So you have a query coming in, and the query goes, first fetch the business data or the data you have. This gives you the context of how to answer a question. And then you take that context based on your data, you take the question, you send that to a large language model and generate the answer out of that. So it's not just the large language model giving you the answer, but it's like you provide your context to the question to give you better answers. Especially if it's something proprietary or specific to your company, the LLM cannot answer that in general. So for example, if I would ask like an LLM, what is my insurance policy? It wouldn't know. But if I give it the context like, oh, insurance policy, this is the insurance policy you have, and then you tell the LLM, it's like, answer the question with this data that you have, then you get a much better result. And that's the idea of RAG. And Elastic is basically the R, the retrieval, and then the generation is OpenAI or Bedrock or whatever else. And LangChain or Llama Index is kind of like the glue or the augmentation in between to keep all of that together. That's how I would quickly describe all of those 3. And yeah, this is how you pull all of that together. We have a playground, and I'll just show you in the playground to make that visible. And by the way, you can host all of that on-premise yourself. We have a hosted cloud service. We have a new serverless offering that is getting closer to GA as we speak. So you can run all of this wherever you want. I'll use the hosted cloud service for today, but you could put it wherever you want. In all the cloud providers all around the world. So wherever you want to have your data, whatever jurisdiction you need, that's all doable. Plus, high availability, security, support from us, everything is possible there. So let's dive into that demo. How to do that is we have the playground here, and we need to do two things. We need to connect a large language model. And sorry, let me move my video here out of the way. I'll pick OpenAI, and I'll call it my OpenAI connection. And then it says OpenAI, let's say we have ChatGPT 4.0. I need an API key. Let me quickly copy that from my password manager. And if everything goes right, nobody will see anything. See? Okay, we have connected that. I don't want to save it again. We add a data source. I will pick my semantic Star Wars index. So any data that you have stored in Elasticsearch can be the foundation for that. We'll save that. And now you have this AI interface here. So what you basically have is you can now start asking questions against your data with that LLM of your choice. And you don't have to build anything in Python or JavaScript or wherever else. You can just do that you can just try that out.
So you already did the embedding for the data already, right? I mean, it wasn't done at the time of, let's say, ingestion. Are you ingesting the data here?
No, so that the data is already ingested. Now I just have like this chatbot-like interaction based on top of my data. So we can pick a model. Let's go with 4.0. You can pick like how many documents you want to retrieve for the context. I'll leave the default for 3. You can pick which field you want to search on. I'll go with quoted. It doesn't really matter. Or you can play around like how that connects. You can also see, by the way, the query. You can enable and disable which fields should be searched. And you can tune this query. So this uses RRF, what we have talked about. So we are using the query that I run against all the 3 ways I have stored the data, and it will re-rank or merge it together with RRF. You can customize this query, and you can then just start asking questions. And we can ask it, who are we looking for? And then it says, we are not looking for droids, which is kind of right and kind of wrong. And I've included the citations. And you can change the prompt. So this is the prompt. This is where you tell the large language model, you're an assistant for a question answering task. And then after that, it pastes in like, this is the context. So it runs the query, retrieves this document and pastes it in, and then it says, this is what you get back. So let me rephrase my prompt to see how that goes. Only answer the question with the context provided to you. See how that goes. Let's regenerate that. I feel like this is the slight demo effect of the LLM being.
You need to get a response from the vector database rather than from the context.
Yeah, so let me show you. I have only answer with the context provided. It was even the same prompt. So the thing is, how this should look like. If you ask like, who are you looking for? It can then say, I don't know. Whereas if you say like, who are you not looking for? Then it will give you the right answer. But that is the trick of prompting, that depending on how you prompt exactly, that it changed. And here I had a slightly different model. Yes. So
did you lose the face value? I'm not sure how it's defaulted that focus.
Yeah, it seems like it's just negating the wrong part of the sentence.
Let me check. What else?
Could be a UI bug is my point.
Turbo. Let's see if I regenerate that. If that.
Deterministic computing.
No, it's not exactly
boring.
deterministic. So we might have to play around with that to get exactly to the prompt. But you can see here how to put all of this together, change the prompt to get to the answer that you want. And then it will actually start talking to you. The two remaining points that I wanted to make here is first, once you're happy with all of this, you can export all of the code. So we provide that for both Python and JavaScript. And you can just copy out this and then customize it in your application and run it wherever you want. So this is really just a playground to get you started quickly.
And in your prior manage dialog with a little tool tip underneath view code on the right there, what does that unlock, the manage? Anything? Underneath the, sorry, I was going too fast.
This one or?
No, the manage.
So this just manages my connectors.
So when you set up your connector, you still got a default model set to GPT 4.0.
Yes.
But when you went back to your UI,
yeah, it did not stick.
3.5.
Yeah.
that's assuming the label is correct and all that other jazz too. But would that have been disclosed? Let's go look at your code.
Yeah, the
Let's go
code
look at
should
your
actually tell. I mean, so whatever I have picked here should be actually in the code. So I assume. Yeah.
Yeah. No.
So this one will export the right one. It's just the default that it picks.
Interesting.
But this should get you started really quickly. The other thing that people often ask then is, what does this cost? And actually, it's very cheap. Let me refresh that page. So I've been running this a couple of times today. And I think I'm still only up to like 5 cents.
Oh, you're not even a 20-cent demo. Okay. Yeah.
Yeah, I'm even running this from a private account because it didn't even make sense to get into a company account. But you can see I had like 31 requests because the context is so small. If you have larger documents or more documents, it will of course get more expensive because you pay for both input and output tokens. But in the very minimal way that I've been running this, like we only used a couple of thousand tokens, so it's really, really cheap to run.
That's what I would have expected, like 20 cents. So you're well below my expectation.
Yes, but I mean, my context was also super small.
Yeah.
So don't take that and say like, oh, this should only cost like fraction of a cent.
You have 2 quotes in there.
Yes, it was very limited context. Yes. So the more context as input you have, the more expensive it will of course get.
So it's cost me a bunch of money to not get an answer multiple times, and I have to keep guessing.
Well, guessing is like once you set this up properly, and then you will need to start debugging. Is like, what do you retrieve and how do you prompt it? And that is, by the way, the other tricky thing. Depending on what model and model version you have, you'll need to change your prompt.
But
that's
a feature of AI, not a feature of Elasticsearch.
Oh no, I get it. I'm
Let's be
just
fair to
Yeah,
Elastic here.
This isn't the
That's
SCSI
fine.
error you're looking for.
But if I'm the business and I'm going, I look at this and going, why am I doing this again?
So the
You get
interesting
better results, which we
you get
argued
better
about
results
before.
faster. Hopefully.
Will you? Awesome. When? Yeah. So
Well-
you didn't, but you will soon.
Oh, well, you don't show them this stuff, the learning curve. Well, it's learning curve for us.
Also, this,
I get what you're saying, John.
Yeah. It's like this feels like the opposite of progress.
now I want to make note of the naming here. The playground. Why not studio? Why not lab? Why not? Does playground convey, or is it intentional in conveying that this is it's a
More like I would say the getting started point.
okay.
Like this is where you get started very quickly.
It's the learning.
So
hub.
when you
then you
created
input it.
when you created the data, you stripped out all the stop words,
Yeah.
you stemmed it, you did a lot of things. So the word "not" didn't even show up in your data.
But it did
Depending
in the
on the model.
vector. It's in the vector. It's not in the
Yeah.
semantic search.
If you use depending on which of the 3 fields you use.
If you use quote, then it's a text.
Yeah, then it's stripped out. Yes.
And you used quote to do the search?
No, I think it.
Use the vector.
Let's. Who are we not looking for? Let's see what happens now. We are not looking for droids. Okay. Who are we looking for? See how moody my LLM is. Okay.
Now do that with a quote. Search.
See what, but it might just not. Okay. Now I managed to get it to say, I don't know. That is, by the way, one of the harder things that it actually admits that it doesn't know, because that's, I think, one of the problems of LLMs, that they are very confident in giving you the wrong answer potentially.
It doesn't know the capital of the state of, like, it doesn't know the capital of Kansas.
Yes.
Okay.
Where we generally see this work really well or have wide application is internally, because you have users who want to get the support, whereas malicious users are very hard to fight. I think there was this well-known case with a Canadian airline where somebody tricked the LLM to say, like, you can cancel your flight for free.
That was the
Yeah.
And that stuck.
Or buy the car for free. One of those two.
that was a well-known
Yes.
example earlier.
That's a well-known
Yeah.
example where they
Yeah.
prompt engineered the LLM to give them free access.
So malicious users are tricky, and we'll see how that develops. But internal users who actually want it as a support tool, and who will do some validation and only use it if it makes sense, are a much more sensible use case.
And I think the
Assuming
trade-off is, sorry, go ahead.
assuming that there are no malicious insiders,
Yeah.
because that never happened.
Yeah. So I think the trade-off is, like, if you want exact answers with no flexibility, you'll just use 1980s text search,
Keywords.
where not just keywords, but spelled and capitalized and apostrophed, and
Oof.
I know, but you know the days.
Grep minus Y.
And so that will help you have more confidence that you got an answer that exactly matched what you searched for. It's just, we've all seen, like, you sit next to someone who's just doing a Google search, and they sit down and they're like, show me all the cars I want. And you know that old school Google search is not going to know, it's going to search for those words. So for me, the trade-off is you deal with a little bit of this uncertainty on how it's going to answer you. But then that becomes, like, as we see, everyone posting the wrong answers on how strawberry is spelled and all of those things. That
Something about skunks. Or something.
Yeah, cats and croissants, those two things. Yeah.
But the point here, is that
Yeah.
I think let's be clear. What you've shown
Yeah.
is really simplifying the process
Yes.
of building RAG. And we had earlier Ignite talks, and Calvin has done a talk on the effort he went through to build a RAG. And this is a greatly simplifying process. Whether that's immaterial of all the limitations of Gen AI. And if you're putting this into production, you're going to put guardrails around this. If you don't put guardrails around this, that's, you just like you have to put guardrails around any application. Your expense report application has guardrails built in so that you don't approve. You don't call your boss and say, approve me for $10,000 of flights, first class flights to Japan.
I do.
Right.
I
Right. We all have those guardrails, right? So
respect your optimism.
No, I think what you're seeing here is, like, this greatly simplifies that process of making the RAG application.
Yes.
So I feel like the real way to get the next level of this is you're going to need to have multiple models involved in the situation to have the guardrails in a way that you can do things you don't anticipate, because the other models can intervene on your behalf at different temperatures and different creativities and different, like, context.
You might have a model that validates your output before actually sending it to
Right.
the user.
But it sounds like the playground out of the box.
Validates before it's sent to the.
But all Elastic is doing is he's got you connectors to these models, right? He's not
Right.
there. You're not building the model, right?
Right.
Yeah.
We're the retrieval.
They're the retrieval part of it.
We are the R.
Now, going back into view code one more time.
Sure.
What is the if you're a product owner, what is the expectation of what someone's going to do when they copy that? What would they do with it?
I mean,
Where would they go? Would they go way outside the Elastic system? Would they stay inside the Elastic system?
oh no. So this is wherever you run your production application. This is just, it's connecting you to the LLM and Elasticsearch for retrieval, but then you run it wherever you run your Python or JavaScript application. So we're not a hosting provider. We don't want to run your code.
And so at the very top of this Python, what is
Yeah.
the expectation of the environment? So you've got
So
Elasticsearch, okay.
Yes, it installs your dependencies.
Which is whatever number of manage connectors that you have specified, and
Yeah.
those would all be included. Okay.
Yeah, so you can really spin this out quickly. And this is a prototype or the getting started point, but this is not application development. And this is not an IDE. You don't want to write code here.
And is there assumption that they've somewhere set this environmental variable for the key?
Yes, so that we try not to paste any keys here. So you would export your key.
Okay. And so they would.
So it's
okay.
like it tries to look for an environment.
But there's no comment to say, hey, I think you need to do the following.
No, so
Okay.
You mean we should add a comment?
No, I'm just saying there's it's not conversational comments as to what one would do. This is just if you experience pain while trying to develop your application, here's something you can go back, look at this as this would be functional if you had a properly established environment to execute. Okay.
It's all to refine your search outside of your application.
But that application code, I can't change the application code and run it in your playground. You're saying I can download that myself and run it like a big boy.
Yes, you need to do that properly.
Yeah,
we are not a hosting provider.
Yeah.
The Elasticsearch is not.
This is a Jupyter notebook, is essentially
basically a really limited one.
Yeah, it's a starting point to get you.
And it's not doing the code. It's not going to give you like, please enhance my code.
No, it's not a code.
Copilot. It's not a copilot function. Things like, and this is where I was like getting with it's a playground. It's not a studio.
Right.
We're not GitHub or GitHub AI assistant or whatever it is. I wanted to close the loop on the earlier question about the security assistant. So the first thing is what you add. If I find the right screenshot here. You add the LLM. So we don't build an LLM ourselves. We don't have our own LLM. So you can add Azure OpenAI or whatever else. For security, we have found that Claude works very well. That maybe recommend to start there is too strong, but we have just seen that Claude works very well. And then you can also say, for example, which fields to anonymize when you talk with the assistant. But this basically plugs the LLM into our data, and it's slightly different than RAG, but it's kind of like the same thing. Like we have all the data, and we have collected it from the process information or the events and everything, and we connect that retrieved data with the generation to answer your question. And then you can go in and say, like, explain this security alert to me. Why did it trigger? What were the reasons for that? Or you can go one step further and say, like, give me all the activities of that user or that host to just dive into that, rather than having to slice and dice through dashboards or write queries yourself. You can just have a more conversational way of exploring your data, both for observability and security. It could even give you a dashboard or a visualization. Like, for example, to say, like, show me the latency over the last 24 hours of the service X. It could just show you the visualization. Or you can say, like, tell me the average latency, and it will tell you, rather than you writing the query.
And anonymization, again, was what?
So you could say, for example, which fields to filter out. That there should be no IP addresses free. Because especially if this goes to a public LLM, maybe you don't want to send some information.
So it is masking before sending.
It could do that.
Okay, all right. Could do that.
Which is an important feature when you have public LLMs. I hope we quickly touched on that.
The other part of the question was, how do we train attack discovery to identify anomalous behavior? Not the AI assistant part.
Not necessarily the
about
training, but
remediation.
what exactly were you doing for anomaly detection?
Yeah.
So there are multiple pieces here. So we have detection rules, which are made up out of, this is the right page. We have a lot of built-in rules. And it could be like, there is a query that runs, it could be a machine learning job that says, like, give me a process that suddenly starts using a lot of CPU, or a process that I've never seen before. Like, for example, rare events in security are very common. And we have various machine learning algorithms around this more anomaly detection of things. But there are also like process behaviors that are very suspicious. For example, somebody opens Outlook and then clicks on an attachment. And then that attachment, which is a Word document, spawns some exe file And we could follow this chain basically, and that would trigger because it knows that this is a very suspicious behavior, and you could define things like that. So we have this event correlation where you have like this combination of things that's wrong. We've seen this before. This shouldn't happen. But there are different ways how you can combine them and write them, and we have like a couple of hundred rules built in of suspicious behavior, but you could write your own for your environment.
Yeah, so the detection is specific to Elasticsearch functionality.
Yes.
Okay.
So we collect a lot of data, and then you define the rules on top.
I got it.
And then the RAG can basically interact with it and explain, for example, what is happening.